Okay. So we want to calculate the first. First is a bit easy because we just go through the entire production rules and then we're done, right? So what's the first of, well, first of all the terminals are easy. Okay, so sorry, this is slide number, please read the textbook. For these of you who can afford it. '28. Okay, so the first of the terminals are all taken care of. First of plus is just plus. And then the first of multiply is just multiply. There are two ways of learning this, right? One is you just absolutely lose all your humanity and act as a memorizing mechanical automaton. And you can do this, right? And of course, most of us do things like this. And then right after the exam, right, you regain your humanity, and therefore you lose all possible knowledge of anything, right? And that's fine. You might be able to get a job and so on. But it is not possible to sort of do these like these phone interviews. Who has done one of these like phone interviews with Google or something, or similar, like Microsoft? IBM. Oh, well, maybe IBM is kind of, I don't really respect them that much. But anyway, well, was it hard? But perhaps it's hard. So where they'll say like, oh, well, it's like, can you use a push-down automaton to reverse a stack of cards, right? And then if you have just learned this course mechanically by losing all your humanity to remember, you will not be able to answer that like on the phone interview, right? So try to think of the intuition behind as to why we're executing these steps, right? Algorithms existed after we gained intuition. So algorithms are some sort of an explanation of intuition from one person to another. It's an interpersonal communication, right? Because otherwise, I could just give you a C code, right, or Java code and say, learn from this, right? So for me to explain things algorithmically, it's actually an interpersonal communication. So it's not meant to be memorized mechanically. But anyways, you can do it, and you might succeed because there aren't that many steps to remember. This is the right bracket symbol. First of ID is ID. Okay, so these are the quick ones, right? And I'll probably give equal marks for terminals and non-terminals, and that's just free marks. So pick up these quickly. Except I'm going to have fewer non-terminals, or fewer terminals than non-terminal, so that you can't pass by. So now what we are doing is we want to calculate the first of E. So what are all possible sentences that can be derived from E and then take the first symbol of, right? That's what we want to do. And if E can be empty, then we have to put the epsilon into it. And we just go through all of these guys, right? So here's E, right? Okay, and then you say to yourself, okay, well, the first of a, so sentence that starts, all sentences that start with E also start with sentences of T, unless T can be empty. If T can be empty, then sentences of E can also start with sentences of E prime, unless E prime is empty. And if P can be empty and E prime can be empty, then sentences of E can be the empty string. Right? You see, that's, I mean, I really don't think it's that difficult to understand. It's like, because I've taken things where things are just too difficult for me to understand, right? Quantum mechanics being one, or real analysis being another, right? Or even algorithms and data structure can be too complicated. But this is not too complicated, I don't think. So, okay, so let's take a look at this. So what's the first of P then? Okay? So we can't really tackle the first of E because we don't know anything about the first of T. So you can say, forget it. I'm not going to do anything about that, right? Then I'm going to look at the first of E prime. Well, oh, sorry. I mean, let's do the first of T. Because you can't do anything about E, therefore you do first of T. You can execute the algorithm on slide 28, which I don't remember, so unfortunately I can't do it for you. The first of T is the first of F, followed by, unless F can be empty and so on. So I can't really do anything about that either, so I'm going to say, what's the first of F? And I think we're finally somewhere. So the first of F have two possibilities. It can be the open bracket or ID, right? So it's the open bracket or ID. That's the first of F. There was something pending on the first of F, right, which is the first of T. Good. So the first of T is the first of F, right, which is the open bracket and ID. Can sentences of T start with sentences of T prime? The answer is no, because F cannot derive the empty string. Therefore, the first part of T must be a first part of F. Okay, so we're done with T, and now we need to move to E, right? Because E was pending the decision on T. Because we were doing this recursion. I'm just doing this recursion manually. And that's the open ID. Okay? So there. Now we have other things, right? So we calculated this, and this, and this, and we need the first of these guys. What's the first of E prime? The first of E prime, first of all, it could be the plus, right? Or the empty string.